Sampai mana itu? Sini kan, betul. Ini ya. Yang last tu. So, the last one you understand about orthogonal. Orthogonal projection. Okay. When we got object, something like this. With this position, with this angle, the idea is how to draw orthogonal projection, which is a normal line to the plane. And you understand that what normal line means? It is 90 degree. Okay, 90 degree to the plane. Okay. Orthogonal projections are images formed on a plane when the projected line from an object is perpendicular to the plane. It is this projected line must be 90 degree to this plane, not perpendicular to the object. Remember that, so you might not get confused later. All the projected line must be 90 degree to the plane only, not to object. Object can be in many degree, many position. It doesn't matter. As long as you make a line from object to a plane, which is the line projected perpendicular to the plane. Okay, moving along. Let's say we have, take a look at diagram 3 here. So we are given the object that is PQRS. Then we want to do the orthogonal projections from this object to the plane. And this is how we're going to do it. This point of Q here, let's start with P. This point of P here, we're going to draw a straight line, which is this straight line is, if you can see the symbol, a small symbol there, to show that the line projected is perpendicular to the plane itself. Okay, and so does this point of Q. We put a line to the plane, which is the line is must be perpendicular or 90 degree to the plane, and which is what we got point of B as image of Q. And so does R to C, and so does S to D. Okay, take a look at next example. Here we have object EFGH, which is we construct a line from the object to the plane, in which the line and the plane is perpendicular, as you can see the symbol of 90 degree there. Okay, can you see a small tiny there? So that is the idea. What is orthogonal projection? Soon you're going to create one for you, orthogonal projection. Okay. Now suppose that we have this block here, this object. Now we want to do the orthogonal projection. So, and this is how you supposed to do the same one. We're going to put a line straight to the plane, which is 90 degree to the plane. And you know what? The surface up there is on the same. It's kind of hidden in the plane of below there, PQRS. So let's say this, we take this point of U. Actually, point of U and P is on the same line. This is why we got only one point on a plane, that is A. So A here represent two of these, U and P. Since the point of U somehow been hidden on the same point of P. And so does this V been hidden on the same point of Q, and so does this W been hidden on the same point of R, and so does this T been hidden on the same point of S. What I mean, if both can be used on the same point. Now, if we want to draw the side one, we have to do the same orthogonal projection. We make a line from each vertex. From each vertex we can make a line, which is the line is perpendicular to the plane. Okay, and to get what it look like on the left side. So this, you can see the drawing here on a plane is what represent what it's supposed to look like on the left side. If you look at this side, you're going to see like this, this shape. How about the other shape on the back one here, on the back plane here? It is all this point is been hidden on the front points here. So this is why we got only 2D instead of 3D, if we look at this side. Example 3. Each of the following diagrams shows the projection of an object on a vertical plane or a horizontal plane. Okay, this is horizontal plane, while this is vertical plane, because it stand upright like that. Determine whether the resulting projection is an orthogonal projection. Okay, let's do A. Okay, A is, so do you accept this as an orthogonal projection?
Yes.
Clarify your answer. Why you say yes?
Because perpendicular.
Okay, it's what I want to hear. You say it's because the line projected from the object to the plane, the lines and the plane is perpendicular. Okay, this is what I want to hear. Okay, correct. How about B? Do you accept this as orthogonal projection?
Yes.
Okay, yes it is. Why? Why is it?
Sebab dia punya garis perpendicular.
Okay, because the line projected from the object to the plane while the plane is while the line is perpendicular to the plane. As you can see, the symbol of 90 degree there. Okay, so this also we accept as orthogonal projection. How about C? Do you accept this as protogonal? No, protogonal, no, I mean orthogonal projection. Do you or do not? Which one?
Do not. C kan?
Yeah.
Tak.
And your reason is?
Because it doesn't have perpendicular.
It's refer to what?
Angle.
It's refer to angle because the angle is not perpendicular. Between whom?
Entahlah. Tak tahu.
Yeah, it's supposed to be 90 degree, but between whom? Between the line and the plane. As you can see there, it is not 90 degree, correct? This line here, can you see the line here? And this plane, it is not 90 degree, yeah? Once you tell that it is not orthogonal projection, you must come up with the reason why. Is it 90 degree to you? This line here, projected by this from this object to the plane, is it 90 degree? Is it this line is 90 degree to the plane? Do you feel it? Do you feel it? It is 90 degree.
No.
Yes. It's a no. Why? I don't know either you can imagine it well or not. To find out that the line and the plane is not 90 degree. Yeah? Now, suppose that we have this line here and up at the center of the circle, and so does this. So if I put a diameter there, so now you can see the diameter which connected to this line, correct? And is this line to this diameter is 90 degree? It is not, right? It is not.
Yes.
Okay, so what does it supposed to look like? If you do correct orthogonal projection, what does it supposed to look like? It's supposed to go 90 degree from each point of object, straight, go straight on a plane like that. Wait, let me show to you. Okay, supposed to go like that, and this two straight to the plane. So we got a diameter here. Okay, and the circle is supposed to look like this. This is, then we can call it orthogonal projection. This circle here. Why? Because this line now is 90 degree. 90 degree to the image. Like that. So this is why this is not. This image is not formed from a orthogonal projection of this object. Okay. Okay. Let's do my test 7.1a. Each diagram below shows the object and its projection on a plane. Determine whether the projection is an orthogonal projection. Determine whether the projection is an orthogonal projection or not. Okay. A.
Yes.
Yes. B.
Yes.
C.
No.
No. D.
Yes.
Yes.
Yes. Okay. A student looks at the following object from a given viewing direction. Okay. As you can see, the uh, red arrow here is the viewing direction. It's like your eyes is up there, up looking down like that. Do you understand me? This is your eyes.
Yes.
Sorry, okay, your eyes is looking downward like that. And on this side, also the same. Your eyes is looking downward like that. Okay. So they mark with this arrow next time. They will mark with this arrow your viewing angle, your viewing direction. Which of the following combination shows the correct orthogonal projection? Okay,
A.
we go one by one. Does this is what is supposed to look like when we see on this side of this object? Is this correct?
Yes.
Yes, it is.
Yes.
Because this this square here is represent this square. This rectangle here represent by this rectangle. Okay, correct. How about this? Is this correct?
No.
No. Why? Because
Yeah.
the outer circle here represent the correct one. Outer circle here. Okay, no problem with that. But the problem is on the center here. Center here is not orthogonal projection from this center of object here. It's supposed to look circle too, while this look not circle but a rectangle, which we don't know where does this orthogonal projection coming from. So this is not a orthogonal projection from this object. How do you draw an orthogonal projection? So we are about to this time to draw the orthogonal projection. Will be given many object, many shape, various shape, whatever it is, but they want to see you able to draw orthogonal projection or not with correct measurement, correct dimension. Take a look at this example 4 here. The diagram on the right shows a right prism with rectangular base ABCD on a horizontal plane. ABKLGF ABKLGF. Oh, this front side here, front surface here, is a uniform cross section of the prism. Okay. The sides AF and BK are vertical. Okay. Vertical means they are 90 degree from the base. Draw the orthogonal projection of the object on a horizontal plane as viewed from Z. Okay, Z is we look downward like that. We look downward. Okay. They don't tell look downward. They going to tell only Z. So you know where to put your eyes. Okay. If we want to see what is up on the object, we call it Z. Z view, Z direction, Z viewing. If we want to look front here, we call it Y direction. If you want to look on the side, is what we call X. So keep this on your mind. Okay. Next time they will use this term only. Horizontal plane as viewed from Z. Okay. So how does it going to look like? How will it going to look like? Now we have the same object. Same object. We move here. So if we want to view like this, we want to see what it's like when we look at this Z direction. This is how it's like we put a torchlight up there, downward, pointing downward. We put torchlight pointing downward, and all the what is it? All the what? The dark side we can see the dark side going to appear like this. Okay, with all the vertex being connected like this, which is 90 degree. The line, all the lines to the plane. And this is how you're supposed to draw. Okay. And if we put straight the plane here up to our eyes, we can see the Z side is supposed to look like this. Okay. So here is, look at here, E to H, we have 3 centimeter. So is why E to H is 3 centimeter. Okay, I to J is, it takes 2 centimeter. So thus I to J here, it takes 2 centimeter. Okay, and whatever that left is the length of H to I. On upside, not this incline here. This incline here not 2 centimeter, correct? What I mean whatever left is this. Since A to B is 6 centimeter, F to G 3 centimeter out of 6. So we got balance 3 centimeter. L to K is 2 centimeter, which took 2 centimeter out of 3. And whatever left is only 1 centimeter. So G to L is 1 centimeter. On this dimension, 1 centimeter, not this length, G to L. No, it is wrong on this dimension. Okay. And then because up there we can see all the line is been all the vertices, all the vertices being connected like this, G to H, L to I, K to J, is why here supposed to put a full line to connect all the what is it supposed to connect it with. Okay, what are they supposed to connect it with? Okay. Now we view, okay, this time we view on x direction. So if we draw it on a plane, what does it supposed to look like? This time we use vertical plane because we look at this side. X side is plane, Z side is horizontal plane. Okay, X and Y side will be on vertical plane. So if we put a orthogonal line, and we can see that it's supposed to look like this. Okay, which all the dimension is correct. We take this A to F is 4 centimeter, and this is why A to F is 4 centimeter, because 2 here plus 2 is equal to 4. Okay, B to K is as C to J, 2 centimeter is why B to K and C to J is 2 centimeter. CJ here represent this point at the back here, CJ, and BK here represent the left side. Left side. Okay, so this is left, this is right. B to C, S A to D, S K to J, S E to F, which is 5 centimeter. Okay, so does this 5 centimeter, so does this 5 centimeter. Okay, see, if we view on Y direction, front side, if we view, also the same, we going to need vertical plane, and it is like all the shadows will be fall upon the vertical plane, like that. Okay, with all the correct dimension lah. A to B is 6 centimeter, so A to B here is 6 centimeter. If you notice, how do you supposed to do this? Because A and D here, you can see A and D here share the same point. Okay, and you supposed to put the point whichever it encounter first. Whichever the point that we encountered first, like this, we encountered A before D. This is why you put A as first letter here, and then you put the strike there, and followed by a second point that you encountered, D. And so does this. Between B and C, you going to encounter B before C. It's why you put in front. You put front here before C. Okay, this telling us that D and point D and point C is been hidden under the first letter. Okay. Okay, we got 2 centimeter up there, BK, and then to the left 2 centimeter from this K to L, and on the back J to I is 2 centimeter. Okay, and then from EH and also FG, EH and FG, we got 3 centimeter. Okay, and then whatever left is, because we see this is G to L connected with inclined plane here, and this is why it look inclined like this. Okay. Example 5. The diagram on the right shows a cylindrical object on a horizontal plane. it is given that the diameter of the cylinder is 4 centimeter, A to B, 4 centimeter, and its height is 6 centimeter, A to D, 6 centimeter. Draw the orthogonal projection of the cylindrical object on a horizontal plane as viewed from Z. Okay, so now you know the horizontal plane supposed to be under like that. Okay, so what it's going to look like if we look up, downward like that. So here it is. We do the orthogonal projection, and the shadow supposed to look like that. So here is the result, which is the diameter from this point to this point is A to B, 4 centimeter. Okay. Now you know how to draw the circle. You're going to divide the diameter. You divide by 2 to get the radius, correct? And by using a compass, you put a needle there and you start drawing a circle with with radius 2 centimeter. Okay. If vertical plane as viewed from Y, we know Y is front side like this. Okay, how does it supposed to look like? If we put torchlight on in front here, the shadow going to fall upon the plane on the back, like this. How does it going to look like, the shadow? So it's going to look like this. Okay, you're going to bring the last circle here, and also the last one here, and the last one here, and the last one here. Okay, and this is what it's supposed to look like. 6 centimeter tall, because A to D is 6 centimeter, and the radius A to B is 4 centimeter. The diameter A to D to C, A to B is 4 centimeter. And this is what it's supposed to look like on Y direction. Okay. So here's a little activity for you. If you want, you got a computer, you want to install the software, you do it. You do it. It's up to you. So you see, we got so many kinds of 3D shapes, which is, we don't know how to call it them. It's look like pyramid here. This also pyramid, another pyramid, a cone, cylinder, pyramid, a box, a cube, something like that. And whatever the shape is, it can be million shape, whatever it is. Now let's do mind test 7.1b. Each object below lies on a horizontal plane. Draw orthogonal projections of each object on a horizontal plane as viewed from Z. Okay. And also from Y direction. Okay, this now each and every one of you do this. You do this. Okay, draw the Z. Draw Z with correct dimension. Okay, the tall is 5 centimeter, the width is 4 centimeter, L to M is 4 centimeter too, because both are the same symbol. Okay, everybody, what does it going to look like? You must do this, huh? Then you're going to show to us. Couple minutes for you. Haziq ada Haziq?
Tadi tak ada.
Tadi bukan ada ke?
Yang baru lesson tadi tu dia kot.
Oh, lepas tu hilang lah. Jannah ada. Jannah ada tu. Jannah nanti tunjuk apa dia punya bentuk shape. Aini buat ni, boleh? Aini. Z
Ya,
and Y direction. Lepas tu siapa ni? Aida ada Aida.
Aida pergi follow up.
Ha? Pergi mana?
Dia pergi jumpa doktor.
Ah ya, okeylah. Madiha buat ni. Z viewing and Y viewing Buat dengan dimension yang betul lah. Cuba tengok apa hasilnya nanti. What they supposed to look like. Jannah siap dah, Jannah. Do you have a graph paper with you?
Ada.
Yeah, you're supposed to use graph paper. You have to had a lot of graph paper.
Cikgu,
Yeah.
memang kena guna graph paper tu ke?
Yeah, but if you don't have one, you can use A4 paper. But it's going to be a lot of work for you to do before you able to draw. You have to establish many lines before you can draw some object something. This is the problem if you use only plain paper, no guidelines from lines such as graphic paper. So, have you or not? Okay, now I'm going to show to you how does it supposed to look like and how you're going to construct a line, a straight line. So let's begin. Let's draw this KL line here. And I really suggest you to use this ruler. This ruler is what? It is transparent. It really help you much in when come to draw. So like this, example, you want to draw something on a middle here. So you're going to place the ruler, place this side of ruler to this side of a paper. It's supposed to look like that, okay? Why we do this? To get a straight line. Okay, you take another side to draw a simple line like this, okay. And this is when you get the straight line. Why? Because the ruler is straight. The ruler is straight. You place the ruler, the end of the ruler also at the end of the paper. So this is why you get the straight line like this. And then you're going to do the same for this line KL here. You're going to place, you can rotate this paper like this. Okay, you're going to put, to set the ruler straight on the paper like this, to have a straight line. Okay, like that. Okay, so you see this both line here intercept each other perpendicular 90 degree. Okay, now K to L is 4 centimeter, correct? So you have to place your ruler once again to measure 4 centimeter with K to L like this. Okay, and put a little dot there to mark the length 4 centimeter like that. And if you are convinced enough, you can make the line look, you can blacken the line, blacken. Okay, like that. Make it a little darker like that. Okay, if you're convinced with the line. And so we know that this base here is KLMN here is a square. So it's why the length upwards is also the same 4 centimeter. You may rotate this paper to suit your viewing, to make your view comfort, so you're able to put a mark as well as you can. Okay, like that. And if you got a point, then it's time to make it dark. make sure once you draw, your pencil is always straight, straight upward like this. Okay. And now to draw a straight line up there and to the right, horizontal. And this is where the problem comes once again. So you see, I know you kind of want to make it quick, so you just, you know what, you just assume. You just assume, is it like this to the right, to the left? You try to adjust it so you'll get the straight line. But you know what? It is wrong. It won't help you. Unless if you somehow got a skill, you know how to, you place your ruler like that, and you can estimate this length to this length is somewhat must be the same, the length. By then you will have a straight line here to there. But still not a proper way to construct a straight line. Do you have any idea how do we supposed to do this correctly? This is when the use of compass is a must, is necessary. Okay, this compass will help us a lot to have a straight line. So this is the correct way to have the straight line. So you see, we have this compass. We're going to make this compass, set this compass to the length that we need, that is 4 centimeter. Okay, now change the place, put a needle on the other hand. We're going to draw a little curve like that. Okay, and because this is also 4 centimeter the height, okay, so you're going to do the same on the other side like that. Okay, and try to draw a curve, a little curve there. So both curves meet on some point there. Guess what? If you connect this point to the point under, and you're going to have a straight line which is 90 degree. Okay, believe it or not, this line is 90 degree to the base. Now you have both line up there, you just connect it both with another line. So here it is, how you're supposed to construct. But we're not done yet. Why? Because as we see from this Z direction, we can also see that this inclined line. Okay, and so does this line. So this V here will be the point on the center. We can see also this top vertex here as V. So this V here is, if you can see, if we orthogonal map to the base here, we can see the point of V going to be on the center between K to M and L to N. So this means that to get the point of V is not a big problem. We just set a ruler like that, and because we convince enough the line, you can darken the line already like that, huh? Okay, see, and so does this side, huh? Because we convince enough the line. Okay, so here it is the point of V, as you can see. Now there's nothing left to draw. We got all the points. Now it is time to put a label, huh? Now here is the label is K to L 4 centimeter. So here is K, and here is L. Okay, on the back we have M, N. Okay, so here it is M, and here is N. And on in the middle we have V. So here it is a V. Okay. Any else? Anything else? Nothing, huh? So here it is. The images, the image of the object if look on Z direction. Okay, this is what it will look like. Okay, any question? Now we're going to draw Y. We're going to draw Y. You know what? Since I got this this Z direction already, guess what? I can share this dimension to draw the Y viewing direction. KL I got already. KL here 4 centimeter. If I want to draw it up here, so I've been the idea is I already got the dimension that I want, so I just do the another orthogonal projection from the image that I got already. So this is this point of V here. I'm going to construct a line from the point of V up to the upside. Okay, like that. I'm going to draw it like that. But also the same, we're going to adjust the ruler, so you might get fixed. You might get as straight as possible. You can. This is why. This is when the what we can see through here. We can see through passing this ruler. Transparent. Okay, this is when transparent ruler is really help much. So by assist from the ruler, I can make the straight line up above. So the idea is, if you see this side, you try to timing the length. This length must equal to this length up here. Then you will have the same the straight line perpendicular to the object and image, like that. Okay, do not press your pencil yet, because we just want to have a line, an assist line, an assist line. If we convince, then we can start darken the line. If we don't, we just put the lightest as you can. It acts just like a grid line on a graph paper. So there it is. We have this two line here 4 centimeter to each other, and the line on a middle. And the same, we need to draw K to L. K to L is 4 centimeter. Okay. So according to this line MN here, I can place the ruler. So I will have the straight line as I can, straight horizontal line like that, because I convinced enough is why I construct and bolt the line already like that. Okay. And what is the height of this object? The height is from V point to the center here. It takes 5 centimeter. So notice that 5 centimeter here is referred to the height, not the incline here, not the inclined line here. Inclined line here is a hypotenuse. Okay, 5 centimeter here refer to the height of the object from V point to the center of the base. So we're going to construct line from the base here is 5 centimeter. So this point we're going to connect to both ends, left and right. Okay, V to K and V to L. Okay, we convince we can darken the line, and so does this side. Can darken the line like that, and there it is. Okay, it's what it's supposed to look like when you view on Y direction. Okay, now you may ask me what happened to this line VM and VN on the back. This line here VM is hidden on this line VL, while this line here VN is hidden on line VK. So this is why we only need one line only, because both line is on the same line. The back one is hidden on front line. So we have, okay, now put a label. This is K, this is, now remember that the one that we encountered first, we put at front, K, and then followed by N. Okay, like that, KN, LM. L come first, then followed by M, like that. V is only a point up there, V. Anything else? There's nothing more. So here it is. To draw the Z viewing direction. Any question? When we finish our class?
10.40.
Okay, we got another time. Let's do number 2. Have you done this? Have you done this? Aini?
Yes.
Okay. Never mind, I'm going to show the same too. Number 2. Okay, so you know the process. Now we're going to look at this side as Z side. So how does it going to look like? But we're going to see the circle, right? The circle, which the top here, see, is going to be in a middle of the circle. Now I'm going to construct. We're going to construct the horizontal middle line here. Stand for C. Here come the problem. We don't know how to. If you want to draw it in the middle of the paper, we want to draw it as straight as it can be. But this come the problem. We do not use graph paper. We only use a plane of paper. How do we construct a straight line passing through the middle here? Okay, the same idea by referring to this edge of the paper. It could assist us to make a straight line in a middle. So all you're going to need is also a compass. A compass. The idea is to, if you can measure let's say you measure the bottom here, the bottom of paper. Okay, you put you place your ruler at the end of the paper like that, 0 centimeter to begin with, 0 centimeter, and let's say it will last at something in the middle, let's say 7 or 6 maybe, 6 centimeter. Okay, like that. You're going to put a little dot there, you mark a little dot there. Okay, and up there also you're going to do the same. You're going to place the ruler at the end of the paper on the left side here. 0 will be the last, and then followed by 6 centimeter as you did before at the bottom. Okay, like that. This time you got 2 dot up and down. Now you place your pencil on the dot, and then you close your ruler to both dots, and then you're going to construct a light line like that. So this is when the line is straight, very straight, perpendicular to the edge of the paper. Now we have this straight line C to the center. Now then what you're supposed to do is you mark one point to become the center of the circle. You're going to have this center. So you can mark it anywhere. Okay, let's say I wanted the center to be there. Doesn't matter. What matter is next you have to use a compass to have this radius of circle. What is the radius of this circle? It is 4 centimeter divided by 2.
2.
That is 2. That you're going to set this compass to 2 centimeter. Okay. Make a little hole on your ruler. Why not? It will help you much. Now set the compass to 2 centimeter like that. Okay, the pencil must be as sharp as it can, so we will have a sharp drawing. Now it's time to draw a circle by a compass like that. Okay, because make sure that the needle is attached very good before you draw a circle, or you might get a double line like that. Okay, because I really convinced with this is why I darken the circle. So here it is. Here it is. What it's supposed to look like on Z direction. We will have to see this C as a center. So this is the center here. Okay. And A and B is the diameter. So this is A and this is B. Okay. So this is what the cone look like on the upper side. Okay. Anything else that we need to do? Nothing. No line we have to do from center to the circumference. Why? Because the surface is what? Is curve. Curve surface. Curve surface. This is why I got no line. Okay. Now let's draw Y direction. The base we have 4 centimeter and the height is 5 centimeter. Guess what? Because we have this already, we just need to make orthogonal line to the downward, so it will help us to draw the Y direction. Okay, and look at this circle here. We need to draw the tangent. We need to draw the tangent line to this circle. Okay. Okay, so we're going to draw the simple line as a guideline like that, and so does this side. Okay. Okay, now let's construct the base of the cone. So you see I got this end of paper as a guideline for me to draw a straight horizontal cone like that. Because I convinced enough, I darken the line like that. Okay, so this circle here, if we look on this y direction, we're going to see it A to B as a straight line, right? 4 centimeter, and from the middle to up there, see 5 centimeter. So let's construct 5 centimeter. Darken the line, and so does this side. And here it is, y side. Okay, the dimension A, B, and C. So this is A, this is B, and this is C. Okay, this is how you do the projection, orthogonal projection. You got one one image. You can make another orthogonal projection to make next image. They will help each other to construct all a tree of direction, a tree of viewing direction. There is Z, Y, and X. X, Y, Z. Okay, now the last one. Let's do this. I'm going to need another paper. So here it is. I got another paper. I'm going to fold the paper so it will fix the camera. You do not have to fold the paper. I will have to fold the paper so it fixes the camera. Okay. Like that. So before we able to draw the orthogonal from this object, as usual, we're going to need to set up the straight line, left and at bottom here, as a beginning of every drawing. Okay, because you cannot draw the object close to the line of the paper, give it some space. Try to make it in the middle as you can. So without wasting our time, you're going to place the ruler like that at the end. Timing the end of the ruler is the end of the paper. Okay, like that. I'm going to draw the lightest, the light line. It will help us. It will help us much later. Just make a straight line, the longest line as the longer as you can. Line. Okay. Now we got this point. This point is a beginning of point A here. The beginning of every point that will come in later. Okay. Now A to B 6 centimeter, A to F 4 centimeter. Okay. 6 A to B 6 centimeter. And A to F is 4 centimeter. Okay, 4 centimeter. Okay. So you see this H to I is, it takes 1 centimeter. So means that A to L is 3 centimeter. 3 centimeter. So A to L here is 3 centimeter. So guess what, we going to measure already the length. Why not? Huh? Draw as mark as much mark as many as the dot as you can, because we're going to draw the line, all of them together. Why not? Okay, and then we have this A to K here, which is 2 plus 2, because they use the same symbol there. 2 E to H 2 centimeter, I to J 2 centimeter. Okay, so it means that from F to K is 4 centimeter. Okay, A to B is 6 centimeter, F to K is 4 centimeter. So why not we mark the length already. Okay, so here it is 4 centimeter. Okay, other than that, that is enough dot that we have to draw this Z direction. Now it is time to draw. Okay, A to B is a straight line. Okay, we have straight line here, A to B. Okay, F to E is a straight line. It takes 4 centimeter, straight line, like that. Okay, now we have E to H 2 centimeter. E to H 2 centimeter. Here E to H 2 centimeter. We still have no mark for that. Okay, there it is, 2 centimeter. Now how do we have got this point? Either you try to draw it directly like that, but we afraid that the line is not perpendicular. Is why we need this compass to make a straight line. Okay, we're going to do the same for each corner. Now we got 2 points, we can darken the line like that. Okay, so does this. Okay, and E to H 2 centimeter. Okay, and I to J also 2 centimeter. Okay, so here it is, the Z direction of the object. Okay, now let's do Y direction. Because we already have this dimension, we just need to do the orthogonal line to help us to get Y direction. Aduh. Okay, here it is. Okay, this is 4 centimeter. The height is 4 centimeter. Okay, centimeter. This height is 3 centimeter. Okay, and we need nothing more. Okay, just like that. So here it is. We convinced enough. We draw a straight line like that. This we take 1 centimeter downward like that. Oh, sorry. That, okay. K to B here is inclined. K to B is inclined line. Just like that. No need to measure the length of this hypotenuse, because we got 2 points already. We just need to connect both of them. Okay, last one, and there it is, Y direction. Okay, if you look on this side, is what it's going to look like this. So any question? No. So
No.
we're going to do more drawing after. So prepare all your apparatus, stationery. Jumpa lagi. Assalamualaikum.
Thank you, cikgu.